Hello and welcome to our presentation today by Advanced Handling Systems, a full-service provider of integrated fulfillment and distribution solutions within the supply chain. We're here to discuss how best to utilize AMRs to extend the life of existing capital. This presentation will give insight on various ways to protect your investment through the use of AMRs and where to deploy the technology within your operation. Our presenters have a combined 50+ years of experience in the supply chain industry, so now let's welcome our presenters. We have Dave Tavel, the Chief Research and Development Engineer. Dave is a supply chain professional specializing in process design. He has over 40 years of experience in the evaluation, design, management, and sales of sophisticated distribution solutions. So thank you so much for joining us today, Dave.
Thanks for having me. Glad to be here.
And we also have Zach Bain joining us, Director of Innovative Systems. Zach has over 15 years focusing on outside-the-box automated solutions in a multitude of industries. He focused on driving innovative strategies into the supply chain industry, particularly robotics and goods-to-person technology. So glad you could join us as well, Zach.
Thank you very much.
So great to have you both here. So let's kick things off with you, Dave.
Everybody, thanks for joining us. Today's discussion is really going to talk around strategies of how to deploy this technology and perhaps where to deploy it without having to change major infrastructure within your existing operations. So as we start this discussion, we have an awful lot of clients that have recently purchased solutions probably within the last 5 to 6 years. And a lot of that capital is still on balance sheets, right? It's still being depreciated. And what we want folks to consider is not abandoning the technology that they're currently using, but enhance it. And so hopefully you'll get some thought-provoking ideas from today's presentation and be able to consider this technology in the future. So we talk about protecting, and extending the life of capital, but really it's protecting the investment. When I talk to CFOs and accounting folks within our client base, it's critically important to fully depreciate and get the return on investment of their equipment. And we've been quite successful of late enhancing that again through the use of AMRs. So I wanted to start with just giving you some foundation of some traditional type material handling solutions that are deployed in the market. The rendering that you see in this slide shows to the extreme right a massive pick structure, basically a pick module that encompasses over half of this facility in square footage. But when you consider each and every level of that pick module, it's virtually 2 times the size of the overall facility. So it creates a tremendous amount of opportunity for storage, but it also creates the demand for labor to walk that distance to pick orders. What are the challenging technologies to this? Well, if you were to undertake this type of a solution today, you might consider a goods to person using things like shuttles, storage and retrieval systems to eliminate that walk. But here we are, you've made this investment and you have this pick structure and it's still on the, we don't want to abandon it. How do we enhance that? And so the way we're going to talk about that today, and you'll see examples of this later in the presentation, is through the utilization of mobile robotics, whether that's a follow me type strategy, using robots through a pick system, a swarming type strategy, but it's basically the focus is to try to reduce wasted travel. Here's an example of an omni-channel environment where not quite as large a pick module as far as space within the facility, but a tremendous amount of traditional rack. And so in this omni-channel environment here, we're talking about a replenishment demand to keep the forward pick area stocked. And so there's a tremendous amount of demand for labor to drive lift trucks, pick reserve inventory on stock pickers, bring that forward and restock pick modules. So we're going to explore opportunities on how to utilize AMRs to reduce that burden and again, extend the life of this solution. So the strategies of where to deploy, when we look at the opportunity to enhance our clients' environments, we focus in on the non-value added transportation. So we already talked a little bit about picking strategies and replenishment strategies, but we're going to also talk about other areas where you can see a benefit through the utilization of autonomous mobile robots. So quickly, receiving to put away, traditionally that's a labor-intensive process. People on lift trucks, you've got the expense not only of the lift, but you've got the labor to utilize that equipment. Along the same lines, reserve to active. So taking inventory from reserve locations, bringing it forward to primary picks, or basically to load trucks. Order picking, as we talked about. Trash handling, something that isn't even thought about, but it's dealt with daily in these environments. We want to keep the facilities neat and orderly and safe. And oftentimes people don't really think about the trash handling, but it requires somebody to periodically make sure that we're emptying trash receptacles and removing dunnage that's created through the inventory locations and pick locations. And then ship staging. So if we are basically doing some type of sequence loading and we need to stage inventory on the dock and then load trailers, another opportunity for non-value added transportation that could be enhanced through AMRs. And then the most recent trend that we're seeing with AMRs is actually the ability to do sortation. And so I know that you all are, I'm sure, aware of the technologies that are in place today where we can utilize AMRs with tilt mechanisms on top to basically sort finished orders into the appropriate carrier location. Or if we are doing some type of kitting in an environment and we need to be able to sort to be able to provide inventory for kitting functions, that might be a strategy. So as we talk about receiving to put away and reserve to active, Zach, your experience certainly heavily in the AMR side. We're showing mobile robots that can lift off of P&D stations. We're showing mobile robots that are basically like an automated pallet jack. And then the newest technology that's been enhanced that we're finding great interest in is automated fork trucks. So Zach, maybe you could share some experience across those three platforms.
Sure, thanks, Dave. So one of the applications that Dave had mentioned was picking up from a stand and dropping onto another elevated stand. However, we're also finding ways where we can receive pallet stacks, receive incoming product, and go directly to an inbound conveyor with the image that you're seeing on the left side of the slide here. And that has a lot of uses and a lot of interest and can deploy very quickly. As we start getting into more larger projects where we're looking at more pickup and drop off locations, and customers are more interested going from the floor level instead of putting pallets on top of racks and then dropping them off onto conveyors or onto another P&D stand. We've kind of pivoted to a solution that is more of a industrial pallet jack where it can go floor to floor level. So basically you could stack pallets aligned on the floor, and starting with the first one working its way through those lines of pallets, it'll be able to pick up that pallet and transport it to the other side of the facility or wherever it needed to go if there's multiple drop-off locations. And then Dave, as you mentioned, with the capability to do a fork truck or a automated fork truck, the capability to pick up off the floor, put them on and put the unit load onto a conveyor for, let's say, inbound to a stretch wrapping machine, or being able to stack pallets on top of each other, or take a pallet from the floor or from an elevated space back down to the floor. And that's kind of seeing the evaluation of each type of mobile robotic solution that we're showing here.
Thanks, Zach. Let's talk a little bit about order picking. We're showing you three examples here. And the first one that you see on the left is basically we won't call it a follow me, but I call it a swarming strategy where Robots are dispatched to pick zones, and they alert the picker for activity to be picked. Again, if we're talking about reclaiming, right, capital, and we talk about these large pick modules that are in play in the industry, this is a golden opportunity to reduce travel distances by efficiently and effectively routing people through pick sequences. When you see this technology on the left, the robot itself serves a purpose, but let's be clear, it's really about the software and how they group the activity that's being picked that drives the efficiency, thus trying to reduce the travel time and the wasted movement. The photo that you see in the center is basically a goods to person solution at a tote level or a carton level. And what this technology allows you to do is leave your rack infrastructure in place and simply modify the rack storage locations with a fixture that allows these robots to interface to it. And so this is a huge opportunity when you consider the huge fields of static shelving that's being utilized in the industry. To think about this in a greenfield opportunity and having to construct that, you have the initial cost of that shelving. Well, if we're trying to reclaim this capital, we're basically eliminating carts, eliminating labor, and we're eliminating lift equipment, but we're reusing the infrastructure that's there and enhancing it through the use of robots. And then to the right is really a follow me solution, right? Where orders are grouped. This would be a traditional, what I would use the term as a cluster pick if I was pushing a cart. But again, this technology is enhanced through the sophisticated software that routes the robots in the most efficient sequence. So Zach, I know that you and I have had a lot of experience dealing with the leadership of these organizations that are represented here. Maybe you can give some insight on some of the opportunities that we've seen with this product.
Sure. So really the two different types of technologies that we're looking at here on this slide are person to goods and goods to person. So as Dave referenced with the two images that are on the outside, whether it's a follow me or it's more of a swarm approach where people are moving from bot to bot to bot in order to do a pick processing, is still fairly labor intensive. It is more efficient than what you would see in a normal picking process, but you're still relying on people to walk from each location in order to do the picking. So there's still walking involved. However, the image in the middle is what we would call a goods to person system, where the robot will actually remove the master case from the shelf and present that to a picker that stays in the same position. So really what it boils down to is, what is the current picking environment? Are there multiple levels of a mezzanine? Are there current infrastructure rack like what's shown in the middle, in which that we could pick up to possibly 12 foot off of? And there's multiple different ways we could utilize the technology to help a customer be more efficient and reduce the movement within the facility in their pick process in order to essentially make the operators and their processes more efficient.
So we're going to talk a little bit about trash hauling and cart handling. And the particular product that you're looking at here is a product manufactured by Mir. And what we like about this product is that it is capable of doing multiple tasks, not just hauling trash. It doesn't have to be a dedicated machine to haul trash. Their platforms are agnostic to what the application that goes on top of these robots. So if we talk about the previous slide, you saw dedicated robots doing a specific task. This product in the market is really an agnostic world. It is whatever you can think of from waste within your facility, we can program, or you can program actually, these platforms to create that task. This one happens to be showing a top module that has a tow hook and the ability to tug a cart. And so we show this oftentimes when we're talking trash handling because of the dollies that are being used for the collection of trash. And then this is just a device that allows you to engage that, take this to a dumpster, and then dispatch the robot off to do something else.
Dave, you hit the nail on the head there. A lot of this boils down to, again, the non-value added transportation within a facility. And when we are talking to companies about entering in the world of mobile robotics and how do they start, where do they start, and what is phase one, or where's their entry point? You kind of say it jokingly, but to really ask them, how can we, how many people do you have going around removing waste removal, trash removal, corrugate removal? So really, those are the different ways that we work with different companies in order to really get them exposed to automatic transportation of different types of things. And then we work to build upon that. So Dave, you brought up a great point. One of the things was, since it is agnostic, we could have this same exact robot doing a specific job, let's say 7 hours out of an 8-hour shift. During that 1 hour that it's not utilized, or it's not being utilized for its initial process, we could task interleave the capability to go around and take trash to specific areas. Or maybe the robot is going to pick up and take a pallet or something to a specific area, and then it's going to go empty back. But what we could do is we could task interleave the capability to pick up a trash container like what's shown on this slide and take that back to another location and then continue on with its process. So really, as we start learning more about the customer, what they're looking to do, their processes, what are they doing on a normal basis and a daily basis, and how can we help make those moves more efficient, is really what it all kind of boils down to, and how we could help a customer.
Ship staging, and Zach alluded to this a little bit on the previous slide where we were talking about non-value added transportation. There's really a couple of platforms in the market today to be considered for this, and it's the autonomous fork truck or it's the autonomous pallet jack. And the beauty of that is, as compared to, say, the previous technology of requiring, say, P&Ds, we can pick up at a floor location and drop to a floor location. This technology will support deep lane storage through its technology on board using LiDAR and cameras, has the ability to position itself in a way and find its product as it's needed. So Zach, maybe you can share other applications. I know specifically the robot on the left, the power head is the same, but aside from being a lift truck, it can also do other things. So maybe you can help the audience understand that flexibility.
That's right. These vehicles are very flexible, and specifically the image that's on the left of the robot there, the power head does have a lift device on it. However, it could also become a tugger robot too as well. So it has the capability to exchange that front end, the power head, to another attachment that has the capability to tug up to 10,000 pounds throughout a facility. So it has multiple uses. One other thing that I'd like to just throw out about the ship staging is when we talk about non-value added transportation, I talk a lot about forklifts or different devices that are in storage. So if you think about ship staging, basically we're going to take pallets and we're going to organize them in order to be loaded onto a truck. So if you think about a forklift going and picking those pallets and then taking those and staging them, getting those pallets out of the rack or a tall storage medium is the value of that vehicle. However, the value of transporting that pallet to the ship staging area, which may be 100 feet or across the building, depending upon where we're picking from, is not the value of that vehicle. So with the capabilities of these two vehicles that are shown on these on this slide, they have the capability to keep the person on a MHE or a piece of equipment that's in the rack doing the value that it brings to the table, and then allowing these robots being able to take pallets, stage them up, and based upon where they're going to load trucks, multiple trucks at a time, and organizing and sorting those pallets to the right locations. So again, it's all about allowing the people that are doing the value-added work on forklifts or other types of vehicles, keeping them doing what's valued to that process, while taking the non-value-added process and replacing that with a robot.
So as we get into the more sophisticated usage of mobile robotics and the ability to reclaim, we talked earlier about what we're seeing in the market today for sortation, using individual package handling AMRs as the ability to sort. Inherently, that is really what the purpose of an AMR is. You're picking up from one point, taking it to another. But now if you think about it uniquely in this environment, depending upon your throughput, and throughput would dictate whether this was a good option for you. the ability to receive unfinished orders and route them to the appropriate carrier destination can be done in a different way. You could install a mezzanine over top of your dock and feed chutes that could fluid load trailers. You could take, again, and through a mezzanine to the floor location to build pallet loads. If it was a kitting opportunity, the same process plays out in that environment as well. The caution here is that obviously you have limited capability for throughput. So how do you increase your throughput with this technology? It's very simple. It's more robots, right? The software and the technology is more than capable of handling that. But this is not going to compete with, let's say, a unit sorter, right? A tilt tray, a cross belt, some high speed, high throughput environment. It really has its place in that moderate to lower outbound rates, but you still require multiple carrier solutions, right, to drive efficiency and cost reduction. This might be an option for you to consider.
Dave, one of the things you talked about was flexibility and the capability to expand and add more robots. And that's really what these technologies bring to the table. A lot of companies that we work with deal with average and peak times. And one of the things that's extremely flexible with utilizing a robot or robots for sortation is you can add or take away robots based upon the throughput needed on your sortation. If you go with the traditional sorter, it is the speed of what it is, right? And you have to buy the full speed that you'll need from day one to day 50 or day 100, whatever days you're looking at within your process and when your peak time frame is. So again, the flexibility of this technology, and we've talked a lot about flexibility of different processes on some of these slides, is really key when you look at using mobile robotics for sortation.
So, would like to kind of wrap up the presentation and talk through some of the basic fundamentals as it relates to AMR technology, as Zach was saying there, right? We're talking to you about strategies on how to extend the life of existing infrastructure so you don't have to abandon what you're currently doing. You can enhance it, right? The purpose of AMRs really is their ability to be deployed quickly. And it really is to eliminate waste. So from a lean perspective, wonderful opportunities here to drive productivity. The scalability of this. When we look at our customer base that we have, and it's heavily influenced by e-com, to think about what goes on at that peak period in a 6-to-1, 10-to-1 increase in throughput, the ability to ramp up and ramp down. Mobile robotics provides that. Again, in the old days, right, in a more traditional vein, you would have to build your solution to handle that peak. Otherwise, you haven't achieved it. So in effect, for 10.5 months out of the year, you've overbuilt. For the 6-week period you have it, you're spot on. So mobile robotics really challenges that paradigm. And so not only do we see this strategy as extending the life of existing systems, it also is a platform to consider for just your overall design of your solutions going forward. Extremely flexible technology. One final thing to leave you with before we open it up for questions is it's constantly evolving. When we put this presentation together in the beginning, to have an autonomous lift truck to reach 32 feet didn't exist, but literally things change daily. So the one caution that I would provide to you all is just be aware, right? What we think is the greatest technology today may be outdated in 3 to 6 months, but that's just the world we're living in today. So with that, I really do thank you all for your attention. I hope we've provided you at least some content that would, allow you to start thinking about ways to drive efficiency in your operations, extend the life of your capital, and we'll open it up for questions. Thank you.
And thank you both, Dave and Zach. We're now going to open up the floor for any questions, so feel free to ask any questions that may have popped up in your mind during your presentation.